Hello everybody, this is Professor Alghamdi Mohammed from Earth Science Faculty at King Abdulaziz University, Saudi Arabia. I'm going to talk about clustering and modeling of wedge failure in late Proterozoic igneous rock slopes northeast of Jeddah. Rock slope failures pose significant geohazards, especially in exposed igneous rocks regions. Influencing factors include rainfall, joints, orientation, and slope geometry. Kinematic analysis and principal component analysis were used in this research for clustering and modeling to enhance stability assessment. The study area located in Jeddah city, Saudi Arabia, with an area of 100 square kilometer, and 11 sites were selected. The lithology of this study area include andesite, basalt, rhyolite, granite, diorite, and gabbro. The elevation of the study area around 1 kilometer above sea level with varied terrain features. GeoCampus as an application of iPhone was used to measure depth and depth direction of the joint in the field. Additional to that, an assumed friction angle, lateral limit, and slope cut were used to feed the depth software to find the failure percentage at different locations. Consequently, principal component analysis were used to cluster and classify the study area regarding the failure percentage. After that, a math model were used to find the relationship between failure percentage at different locations, also to find the relationship between slope cut and failure percentage. Finally, an stabilization suggestion were suggested. Failure percent measured at 30 direction around 360 degree at each side, visualized as polar plot and standard graph to make it easier sense. It was observed that site G record the highest failure rate at 63% in the north direction. The study area was classified to 4 classes using biplot as an extension of principal component analysis. Class 1 include the site G, the direction of the maximum hazards at north. The second class include site A, I, J, and C, the direction of the maximum hazard at northeast to east. The third class include site E, F, K, H, and D, the direction of the maximum hazards at south to southwest. Finally, class B, the direction of the maximum hazards at north direction, but it is represent the lowest failure rate. Correlations of the significantly correlated locations were shown in this graph. It was observed many dots. Each dot represent the correlation between two sites in the study area regarding failure percentage. As shown, correlation E and F reflect a very strong positive correlations, while site E and G reflect a very strong negative correlations. For more theoretical knowledge, the relationship between failure at different sites were presented in this graph. It was observed that the relationship reflects a polynomial of second order. The left graph reflects a negative relationship between failure at different sites, while the right one reflects a positive relationship. For advanced prediction of failure percentage versus slope cut angle, these graphs were presented. It was observed that all locations reflect a linear relationship except location A and G, both of them reflect a polynomial of second order. The slope cut angle reflects zero failure at the maximum failure direction of the different sites were presented here. For example, at site I, the maximum failures shown in 60 degree, while the slope cut angle is 50, while at site C, the maximum failure direction is 130, while the slope cut angle is 17 or less. So less than these angles will reflect stable slope. Conclusions. Wedge failure risk in igneous rock slopes northeast of Jeddah differs by direction and site, with location G showing the highest rate. Clustering and principal component analysis revealed predictable risk patterns and helped identify groups of sites with similar behaviors. Reducing slope cut angle in key directions can significantly lower failure rates, and safe cut angle were set for each site. These findings offer a practical guideline for safer slope design and stabilization in complex geological areas. Future work should include more sites and real-time monitoring to improve risk predictions.